So good morning, this is the streetlight presentation for carbon emissions. My name is Carlos Lopez, I work for Itron out of the US, but we are right here in our global mission. And we wanted to share with you a story that we think is very relevant for cities of all sizes around the world. Here we go. Okay. On this side, we got the electricity production across the world through time. You can see that coal has been really, really important. It was the main part of production since a very, very long time. Increasingly, we have switched to renewables, and the data from renewables has allowed us to do cleaner electricity, right? So we all know that. But there is also a problem, right? It's not only that we are burning cleaner, coal is still very important, and the price of electricity is rapidly increasing. So two very important trends, and if you have been anywhere in the last 2 years, anywhere in the world, chances are that you experience the increase in electricity costs, right? And the forecast going forward is that those prices are not going down. They're actually going to go up. And if you're expecting them to recover eventually, probably not. Right? So we live in a different world, and things that consume energy are going to become a problem, and are a problem for many cities, right, and governments. If you look at the forecast for expected growth of electricity, it will increase by 30% on average around the world by 2030. So it's already gigantic. Now think about what is going to happen in the next few years. But there are good things happening too, right? As I mentioned, there is more clean fuel being used to generate electricity. The carbon use is going down, sadly, not fast enough. What does that mean? It means that a lot of the electrical devices and the increasing demand is generating more carbon emissions. And this has an impact, right, for the environment, but it also has an economic impact for society and an impact for the wallet of cities. So it's a combination of impact to environment and prices that are really changing the industry as a whole, right? So what am I sharing with you all this information right here, right? So this is really interesting. If you look at the US, where I come from, electricity is becoming cleaner, right? If you look at Europe, it is becoming cleaner. South America traditionally has had clean energy in larger part because of the hydroelectric dams and hydroelectric generation. So great stuff. Asia has increased. Africa has increased. Overall, the world is doing slightly better, but the fastest growing areas are the ones that are being impacted the most, right? And you could argue that where we're burning cleaner fuel, in another view, the United States is still the largest carbon emission per capita. So we're getting better news, but it's still worrisome. When you look at cities and how energy is consumed in cities, streetlights are the second largest consumption item on the list and the second part of the budget. So it's so large, in fact, that fluctuations of 5% in the price can flip a city into the red. That bad, right? So the energy saving component, a big concern. Good news is that globally, the 336 million lights, according to the Norris Group, are being converted to LED, who are more efficient on the delivery of and use of energy, right? This trend will continue into 2031, but it is in countries in Latin America, Southeast Asia, where streetlights will take longer to recover and transfer into LED. So they will continue to suffer from higher costs of electricity. If you were to take all the streetlights in the world today, right, they will consume the same amount of energy as Germany. which is the fourth largest consumer in the world. So we're talking about big numbers, 536 terawatts hours a year. If you have not worked with streetlights before or have experienced them before, let me explain it this way, right? On the one side, if you live in a city that has high pressure sodium, the orange glow lights, you will see that the light burns and uses a lot of energy, right? So LED is more efficient. And this is shown this way, right? To get the same amount of light from an LED and a high pressure sodium, you have to spend a lot more energy with the high pressure sodium, right? Which means that if you're paying around 10 cents a kilowatt hour, this is US numbers, right? In Europe, it's like 30-something cents, 3 times as much. And you burn it for 12 hours, let's take an average, and you're emitting 700 grams of CO2 equivalents per hour, right? Then you're consuming quite a bit of money on every street light. And now multiply that by the 336 million lights around the world, right? It's a lot of money that is being spent. What is more interesting is that each one of these lights contributes 505 kilowatt hours. Sorry, the units are wrong in there. 0.35 metric tons of CO2. That's a lot. Okay, let me put it in context for you guys. In a city with 40,000 lights, average city, right? In the US, that will be the average city size. When you do the conversion, you will be saving around $2 million, and you will be burning a year 20 megawatts of power. That is difficult to understand. But if you put it in terms of metric tons of CO2, they will be saving around 14,000 metric tons of CO2. What does that mean? That is around 230,000 seedlings being grown for 10 years to sequester that amount of carbon. That's a lot. It will be around 540,000 incandescent lamps in your house being converted to LED. And it will be the same amount of energy that takes to heat and use electricity in a house for a year, 2,800 of them. That's a lot of energy. If you start thinking in those terms, you can see the scale of what we're trying to accomplish, right? And cities are doing something. This is one of our customers in the Americas, the city of Chicago. They went out to do an enormous investment, right? Because the benefits were so large that in their forecast, they expect to save around $100 million. But there is a second part to it. In that effort, they have become a leader in carbon emissions reductions in the world, right? And now they have participated and are leading a program to reduce carbon emissions in other parts of the city. So there is a change of mindset. It's not only the energy, but how fast can your city go and fit the footprint of carbon reduction, and can you provide a tool to your government to do that effectively, right? So in the case of the city of Chicago, it's 135,000 tons, and the equivalent of 16,000 houses a year. That's a lot of carbon being saved, right? Let me just summarize this, that not only they reduce the carbon, but they also save a lot of money. When you do the calculation, the contribution from the energy reduction is around 90,000 tons. Because they use technology to reduce also the trips that require to fix the lights. The lights have a longer time of service, then this number actually grows. That large a contribution over a period of 10 years. So what is going on? Cities that are pursuing this approach and measuring their carbon emissions, they actually do it on paper. They do it at the time they do the translation, and they rarely look back. It becomes an estimate. But the reality is that cities change. If you go around the city, there are going to be times of the year where you're using more light. There are areas of the city that will require more illumination. There are areas of the city where you might be promoting growth, and there are going to be more lights. There are areas of the city where you need to make your light more efficient for safety, security, traffic management, you name it, right? Add that to the change in weather and the ability to, and the cost of carbon intensity and electricity changes, then it creates a larger problem. that you cannot calculate with pen and paper because it's an organic system, right? A city changes. So the big question is, what can we do? And the reality is that this is an application where technology can help you, right? And it's a tool. It's not the end by itself. So this is a typical street light that is smart. So if you go around your city and you see an NLC on the bottom in Europe, or if you're in the Americas, you see it on top, that's a controller, right? And all of these street lights work together. And what is interesting when you look at them is that they actually know what is going on. You know if it is working, how much energy is being consumed. You also know where the location is and their schedule. Those are the very basic functions, right? And cities like Chicago have done that, right? They measure their schedule and they decided that some lights required to be on from X time to Y time, and they go out there and they do it and they save energy. But what else is going on, right? So this infrastructure that we have essentially is using all the lights. The information is being collected through a distributed network, and then it's connecting to our platform where you can actually see the results of all of this consumption at an independent light level. We're not talking about an average or a pen and paper exercise. We're actually seeing how the city consumption changes. But what is more important is that now you can measure human activity and how it connects to the use of light. So I have a very simple example in here. This is actually a radar that you can see on this side, and this happens to be a bike path, right? So let's help our guy here. Motion sensor detects him coming into the path. You probably experience this yourselves. In Europe, this is not uncommon. The guy goes across. You know how much energy is being generated and used by these lights. These lights also have, because they're smart, the ability to dim. And now that they dim, you know how much energy they consume, and then the effect on CO2. Like, I don't want to make an ad for our product, but it has an energy report and it has a carbon report in it, right? So powerful stuff. It helps you take a problem that is very, very hard to estimate and actually use measurements to determine what the impact is for a particular activity. In this case, bike paths in the city. So let me take this example further. The contributions of energy saving and lights are not the only part, like I mentioned, right? So there are other benefits that have to do with how much more efficient you are at repairing the lights and keep them running. There are additional benefits at making sure that those lights that are broken can be fixed quickly. And if you have gone around in the middle of a city and there are lights on in the middle of the day, that's probably very bad, right? Because those 12 hours just went to 24 and your consumption duplicated, right? These are additional benefits. What does that mean? It means for a city, right, like this borough of London here in Europe, of 330,000 inhabitants, right, with around 18,000 lights consuming this level and amount of energy, right? They went through a transformation. They took the energy, they converted from halogen to LED, and they save a lot of money in the process, right? So let me show you how it looks. This is the benefit of the LED alone. But now they also know and develop a set of schedules for the city that are tailored around human activity. So it's only using one feature that the ones I mentioned, right? Not a lot of cities are using human activity yet. We hope that knowing that it's possible makes them more popular to use, right? So this is the consumption and savings from LED and the emissions of carbon. I just want to mention that in the case of the UK, you have a super clean energy source, right? To give you an idea, it's about 1/7 the one from the US. So very, very clean. And when you look at the impact that it has, right? These different schedules that have been implemented, they serve and save further 3.8 thousand metric tons of carbon, right, in this 10-year period, and an additional 8.3 million pounds on top of the LED conversion. That is enormous, right? So you might be converting to LED, but because you are converting to LED, it means that you probably haven't saved as much as you have, and you haven't saved all the carbon that you could have already achieved, right? So the idea behind this, and the one message I want to leave you with, is that you can actually go out there and measure human activity, attribute it to lights, and then connect and understand what the cost and the impact to the carbon footprint of the city is, right? And let me just have one more slide in here. This is very important. Each street light has a location, so you can define how those lights connect to a particular area of the city, like the bar scene. You might decide at 3 a.m. if there is people grouping on the street, you want to increase the lights. You will know how much is it going to cost you to do that as a city, because you can meter the activity and the consumption at each street light. Then you know, in addition, what the impact is going to be for the city. Imagine now you have the bike paths, you have the bar scene, you have the parks, and you start thinking in terms of how can I manage my city to reduce carbon footprint, and what impact does it have on the overall budget and carbon plan for the city. The final piece is that these sensors are optimized, right? If you just take a schedule, it is blind. It doesn't know what is happening. If you have a holiday and the schedule didn't know about that, the energy is going to be wasted. But if you actually know that people are out there and they're using it, and you can better understand what that is, not only your schedule is going to improve in the future, but also your usage is going to improve in the city. In other words, it gives you a path forward to have better city planning, right? When you add all of that to leverage the carbon emissions and start thinking differently about the way you go into cities and how you manage that energy plan, then the result is very simple, right? It's not only about converting, it's about actively engaging the community and using this information to provide the time and services they need without breaking the bank. Ultimately, you can manage that balance with this kind of information, right? And that's what I wanted to share with you guys today.